Have you ever circled and crossed out numbers on a 100 chart but were not really sure why? That happened to my daughter last year. She was doing an assignment on prime numbers but had no idea why she was circling and crossing out numbers. Can you guess what she was actually doing? Yeah, that's right. She was using the Sieve of Eratosthenes, a super cool, more than 2,000-year-old method to find prime numbers. A method from ancient times that we still use today. But you might be wondering, why are prime numbers so important? Well, imagine trying to build something with Lego. You start with small blocks and stack them up to make bigger structures, right? Prime numbers are like the Lego bricks of maths. You can build any number using primes. And here is something mind-blowing. Every time you buy something online or send a secret message on the internet, prime numbers are protecting your information. They are the key to cybersecurity and encryption. The numbers Eratosthenes sorted out thousands of years ago are still used to keep your passwords safe. But just crossing out numbers on a 100 chart didn't help my daughter understand how prime numbers work. So I said, let's try something different. Instead of crossing numbers out, let's build them with a simple set of rules. Start with 1 and introduce a number card for it. Build the next number by multiplying any combination of number cards you already have. Introduce a new number card only if you can't build that number. If possible, use a different color for each new number card. Let's see the rule in action. My daughter started with 1 and introduced a new number card. Next, she needed 2. Since she couldn't make it using just 1, she introduced a new number card for 2. How about 3? She couldn't make it with the card she had, so she added a new card for 3. Then came 4. What do you think? Does she need a new card? No. She already has a card of 2, and we know 2 times 2 is equal to 4. So she just uses 2 cards of 2 to build 4. Next, what about 5? She needed a new card since she couldn't build it with the existing ones. When it came to 6, can she make it with the card she already has? Yes. She can use the cards of 2 and 3 because 2 times 3 is equal to 6. Now, how about 7? Exactly. She needed a new card for 7. Then came 8. She built it using 3 cards of 2, 2 times 2 times 2 is equal to 8. How about 9? Can she make it with the card she already has? Yes. She can use 2 cards of 3 because 3 times 3 is equal to 9. For 10, she used the cards of 2 and 5 together, 2 times 5 is equal to 10. She continued to build the numbers and her 100 chart looked like this. And guess what? The numbers, except 1, with only 1 card? Those were the prime numbers. I know you are thinking, why is 1, with only 1 card, not a prime number? Don't worry, we will cover that in a separate video. The rest? They are called composite numbers because they are built from primes. It was like a puzzle unlocking itself, right before her eyes. And that's when she realized, prime numbers are the building blocks of our entire number system. But then something more incredible happened. As she progressed, more patterns emerged to her. She said, now I understand. Why if a number is divisible by both 2 and 3, it is also divisible by 6? Why some numbers have more factors than others? 30 has cards of 2, 3, and 5. That's why its factors are 1, 2, 3, 5, 6, 10, 15, and 30. Why the LCM of 2 consecutive numbers is their product. Can you guess why she said so? Drop your answer in the comment box. This simple hands-on activity didn't just teach prime numbers, it revealed patterns in divisibility, factors, multiples, and even the foundations of LCM, HCF, exponents, and powers. Now learning for my daughter was not about mindlessly following procedures, it was about discovery. Next time when you learn or teach prime numbers, don't just circle and cross out numbers, build them. With simple rules. Start with 1 and introduce a number card for it. Build the next number by multiplying any combination of number cards you already have. Introduce a new number card only if you can't build that number. If possible, use a different color for each new number card. Watch how the mathematical patterns emerge naturally. Step into the world of mathematics the way Eratosthenes discovered it, full of patterns, logic, and endless possibilities. Suddenly, maths will stop being about rules to follow, it will become a pattern to uncover. Ready to uncover more patterns in our number system? Let's meet again in the next video, coming up soon.